Kia ora, year 13. This video we're going to have a look at the visual representation of the loci that's actually for argument of some complex numbers. So before we dive into that, let's have a look at generally the complex number that we have in the polar form, which is r cis theta. This r is representing the modulus of the complex number, and this theta we call it argument. And you have to remember the definition of the argument. The definition of the argument by default is the angle from the real axis, from the positive real axis to the vector of the complex number z. Okay, so let's have a look at the first example. Now, this one says argument of the complex number z is pi on 6. So pi on 6 is same as 30 degrees. So we start from the positive real axis, and it's actually turning anti-clockwise. So that is the default, the direction for the argument. So we're going anti-clockwise to 30 degrees, and we are going to draw the line. It says from z to the origin, the angle is 30 degrees, which is pi on 6. So this line can keep going. So any dots on this point, on this line, can represent complex number z. So it doesn't matter which dot we are at, it always creates 30 degrees pi on 6 here. However, one thing that you need to remember, when it's actually at the origin, the angle is not defined. It's actually not 30 degrees, so therefore we cannot use a solid dot. We have to use an empty dot to show that at the origin, the argument is not defined. Now let's have a look at the second example. We have the argument of the zeta is equal to negative pi on 6. Now this negative is actually saying it's gonna turn clockwise, so which is the opposite direction. So the argument is from the positive side of the real axis, you're going clockwise 30 degrees. So this is negative pi on 6. So any dots on this straight line can represent the complex number z. So this is the visual representation of the loci that satisfy this condition. Now let's have a look at another two examples here. The first example is the modulus of z is equal to 3, which means the distance from the origin to the complex number z is equal to 3. So this actually represents a circle. And here it's saying the argument of this complex number is between 0 and negative pi on 3. So what I'm going to do is I'm just going to draw this first. So it says the angle is between 0 to negative pi on 3, which is negative 60 degrees, so it's going clockwise. So I'm going to draw a... So from here to here is negative pi on 3. So that means it is between 0 and negative pi on 3, so it's this region here. However, there's another condition. It says it has to be the distance from 0 to that complex number must be 3. So I'm going to use another color here so that you can see it. So the distance from 0 to that complex number is 3 and 3. So in fact, this is like a circle. However, because we have to fulfill both conditions, so the parts that we're actually talking about is this pizza slice. So this pizza slice actually fulfills both conditions. Now let's have a look at the second example here. Okay, the second example says the argument of z plus 2 minus I is between 0 and pi on 3. Now, as we have to interpret this correctly, we want to say that z from, and remember from is represented by negative, and we put the brackets on. Because I want to have a positive, so that means this 2 needs to be negative 2, because negative, negative become positive 2. and we have positive I inside. So if I expand the bracket, I actually get exactly the same thing here, which is z plus 2 take away I. Now, so this is actually saying that z from where? From -2 plus I, this complex number, and the angle is pi on 3 and 0. Now, let's start from here. This is where it starts from. So -2I. And remember, the argument is always from the positive real axis. For this case, because it shifted from the origin to this point. So I'm just going to draw a dashed line. So this is a horizontal line. So it was the original positive real axis. So start from 0. And it's between 0 and pi on 3, which is 60 degrees. So this is going to be pi on 3. And because both sides has equal signs, so therefore I have a solid line here as well. Therefore, the whole region in between these two lines, including the lines itself, will be the loci that satisfy this condition. Now, however, there's one thing that I forgot to do is the vertex of the angle has to be the empty circle, because at this point the angle is not defined. So I'm just trying to draw the empty circle here. Okay, that's about the argument for the loci.